My name is Amarelda Voigt, and I will be breaking down the basics of how Tesla batteries work. We will be diving into how these batteries function and their overall use in a Tesla car. First of all, these Tesla batteries have lithium. Lithium batteries are popular and have been used continuously in the past 2 decades. They are rechargeable and they can be created to fit any size, such as a smartphone or a car. Pure lithium has a high electrical chemical potential, meaning they have a tendency to lose an electron more readily than most atoms. That means they are very unstable and highly reactive, even with water. However, lithium can be stable when they are attached to a metal oxide. Tesla batteries take advantage of this by creating a system that forces the lithium atoms to change between a stable and unstable state. They separate the atom from its electron, making it a positive ion, and then somehow guide that lost electron elsewhere, which attracts the positive lithium ion. Once it reattaches back with the lost electron, it becomes unstable again. The movement of the electron between stable and unstable state creates an electrical current. It will be more clear with the diagrams later on in this video, so bear with me. The first image we have is a simple breakdown of a singular Tesla cell. We can see that there are 3 main components: the graphite, which is attached to the copper, the separator, which is attached to the electrolyte, and the NCA, which is attached to the aluminum. The aluminum is where the metal oxide is pasted on. It is also where the lithium will be stable. This region is commonly known as the cathode or positive unit. The graphite is pasted on the copper, and this is where the lithium atom will be unstable, and is commonly known as the anode or negative unit. This image depicts a power source or a load attached above the system, which affects the flow direction of the electrons, as shown with the red arrows. Here we have an image of a lithium battery in its charging state. The charging state is when the lithium is currently in the cathode, or is attached to the metal oxide structure. Attached above the system is a power source with a positive and negative side. The positive side of the power source will attract and remove the electron from the lithium atoms of the metal oxide. These electrons then flow through the external circuit. In both sides of the cells, we see the electrolyte, which is an organic solution, and it acts like a guard, allowing only lithium ions between the half cells. Attached with it is the separator. The separator is a permeable insulator, which also acts as a guard. The reason why we have these guards is to force the electrons to move through that external circuit to create an electrical current. The graphite located in the anode is like a storage unit for the lithium and the electrons. The reason why it's a storage unit is because of its loose structure, making it very easy to store the separated lithium ions. The graphite itself do not interfere with the chemical reaction of the lithium ion cells. Once the lithium ion reaches the graphite side, or the graphite sheet, the cell is then fully charged, and again, the lithium ions are unstable. When the battery is discharging or a load is attached, the positive ion will want to move back to its stable state where the metal oxide is. So then the ions will move through the electrolyte, while the electrons move through the external flow, again creating an electrical current. So we broke down the inside of a Tesla battery cell. Now we will build our way up. The 3 main components: the anode, which is characterized by the copper and the graphite, the electrolyte, and the cathode, which is characterized by the aluminum and metal oxide, are then coiled around a cylinder with a steel core, which makes the cell more compact. This individual cell is then connected with other cells in series in a parallel fashion called a module. This module is then connected with more modules in series to form a battery. So these batteries, or this battery pack, can only store direct current or DC electricity. But the Tesla runs on alternating current or AC electricity. So inside the Tesla car is an inverter, which takes the DC electricity and converts it to AC electricity for the induction motor to use. The motor needs AC to create a rotating magnetic field which causes the wheels to turn, thus moving the Tesla car. So to summarize, the inverter converts the DC energy from the battery to the AC motor. And that is the breakdown of how Tesla batteries function and what their purpose or role is in a Tesla car. Thank you.